Hello, we're going to take a look at a problem involving the normal distribution. We are told that the average amount of DNA that you share with a first cousin is 12.5%. We understand average to be a colloquial word for mean, and so this first sentence is telling us the mean is 12.5%, and we know the mean goes in the middle. So I'm putting that on my picture in the middle, and we know that the mean is represented by the Greek letter U. It says then with a standard deviation of 3.5%. So with a normal distribution, it is labeled by adding to the right, and each of the tick marks represents an additional standard deviation, and we know that almost all of the data is within 3 standard deviations. So we see tick marks for 1, 2, and 3 standard deviations, and I will label those tick marks by adding 3.5%. So 12.5 plus 3.5 gives me a value of 16, plus an additional 3.5 gives me a value of 19.5, and plus 3.5 again gives me a value of 23. We know the normal curve is symmetrical, so going to the left of the mean, we have -1, -2, and -3 standard deviations. And we know from our previous examples that to label these, we will start with the mean, and then we will subtract the standard deviation. So in this case, we will subtract 3.5%. So on my calculator, 12.5 minus 3.5 gives me 9. Minusing 3.5 again gives me 5.5. And minusing 3.5 one more time gives me 2. Now I can move on to my second sentence, and it asks me, what percentage of people do you expect to share more than 19.5% of their DNA with their cousins? So I am going to note where 19.5 is, and it's right on the 2 standard deviations. So this is my line. And because it is asking me share more, I want to shade to the right of that, up here where the 23% is. So looking at this area that I'm shading, I'm guessing that it's a very small percentage of people who share more than 19.5% of their DNA with a first cousin. In order to figure out the actual answer, though, we are going to use technology. So this could be done by calculating a z-score and then looking up the percent on a table, but I think it's honestly actually easier to do this with technology. So again, you see that I was in Blackboard and I clicked on my link to the apps that are from the Dana Center, and then I scrolled down here under distributions to normal distribution and clicked on the link for that. We talked about before that the first image that we see here is just a picture of the normal curve, and we want to use the second tab at the top to find a probability. Once we get into the app, we need to enter the mean, and so for this problem, our mean was 12.5%. We need to enter the standard deviation, which was 3.5%. And then we need to determine which type of probability. So based on our image on our PowerPoint that we shaded, we want the area that is above the 19.5, which is an upper tail. And so by clicking that, you see that the image on this app changes to match my picture with the shading above. And we specifically were looking for 19.5%. And so I type that in as my X value. So then on the app, it tells me that this area above is 2.28%. So I would expect only 2.28% of people to share more than 19.5% of their DNA with their first cousin. So going back here, what is my answer?